Hey everyone, this is Derek, and this is section 3.2, and it's going to be about slope of a line. Slope actually ends up being a really important topic. It's kind of the basis for all of Calculus 1, and will show up in lots and lots of places. So let me go through kind of what it is, some notation that we use around it, and just sort of ways we're going to run into it. So slope of a line graphically. Slope is abbreviated by the letter M. I have no clue, I should look this up, why it's M, but it's M. And slope is defined as rise over run, or the vertical change over the horizontal change. And so if I'm looking at a graph, vertical change would be here, right? Horizontal change is here. And that's kind of a mouthful, so they abbreviate that down to how far you're gonna run and how far you're gonna rise. This little thing, let me write that a little bit larger, that looks like a triangle, is actually the Greek letter delta. So delta y over delta x is another way of saying the change in y over the change in x, which is vertical change, horizontal change. And then this ends up turning into that little calculus symbol dy dx when we take these deltas down to little infinitesimals. So this literally is, this ends up turning into the difference quotient, which is sort of the basis of derivatives, which is pretty much what Calc 1 ends up being about. Not today though. So for today, delta y, delta x, and that's again our change in y over change in x. And you'll see these in the reading questions. Linear functions have constant slopes. So that is like the hallmark of a linear function is, you know, this one, for instance, it's going over 3 and up 2. What it's going to do next is go over 3 and up 2, and it's going to keep doing that forever, right? So that it's going to have that constant slope. So that's what marks out the linears. Let me show you a bunch of examples with this. So for this first one, we are asked to find the slope of each of the lines given. So what you want to do is find 2 points that you can get a good look at. And so for me on this one, it looks like right here, that -1 looks like it's at a place where it's crossing at 2 integers. And then here, looks like right there. And so that's what I'm doing, is I'm looking for 2 points that cross at places that I can read. And then I'm going to do, here's my run. So it looks like we're going to run 3. I always do run first. And then here's the rise. And it looks like it's going up, so it's going to be positive 4. So that would be my rise. So rise over run, over here with it, 4/3. And that is our slope. So our slope is, we're going to run 3, rise 4. B over here, I'll do the same thing. There's this intercept right there I'm going to use. And then it looks like my next good point is right down here. So this one appears to be running 1. But now notice my rise is down, right? So it's actually not rising, it's declining. And this is a negative slope. So it's going, we would say 5 units in the negative direction. If I did my change in here, -1 minus 4 would be -5. So we're defining this direction as we're heading negative, this direction as we're heading positive. So for our rise over a run, M would be, rise was -5 over a run of 1. Don't put that in the computer because that is not a simplified fraction. So make sure that if you have like a whole number slope, that you just type the whole number, not the over 1 part. These next 2, and let me draw these in a little bit darker so you can hopefully see them. So this one is a horizontal line, and then this one's going to be a vertical line, and we'll do a whole thing on that later. But right now we're just trying to figure out what the slope of these are. So let me just pick 2 points. And then we'll figure out the rise and the run. So here, if we go rise over run, so I just picked 2 points at random on the line, doesn't matter what. My rise is 0. My run in this case is 3. 0 divided by 3 is 0, and so my slope for horizontal lines is going to turn out to always be 0, which makes sense. If we're going for a hike and You asked me, how the slope is going to be on it, and if I said 0, you would expecting, right, flatness, no slope. So this is a 0. This is not 0, but often is confused with 0. So here, again, rise over run. If I just pick a couple of points, again at random, here my rise in this case for what I happen to choose was 3, but my run, there is no run. And remember, when we're dividing by 0, that is undefined. Oops. I'm gonna run out of room anyhow. On the computer, it probably wants DNE, does not exist. But in words, we would say the slope was undefined. So for horizontal lines, always going to be a slope of 0. So just think of hiking, 0 slope, nice hike. Undefined, that would be like a cliff, right? So it's all slope. Okay, so then we get one more formula, and the formula part's kind of right there. The rest of it is sort of definition. So slope, when we're given 2 points, x1, y1, x2, y2, I should have that in that box. I'm gonna go back and edit that. So x1, comma, y1, and then x2, comma, y2. We can find the slope by doing the change in y2 minus y1, over the change in x, because that's our run, x2 minus x1. So this change in is the same thing. Well, it's right there. Delta y is, y2 minus y1, delta x, x2 minus x1. So then here we're gonna find the slope of these just using the formula. So this time we don't have a picture to look at, so we have to do it a bit more analytically. Doesn't matter which one you call the 1s and which one you call the 2s. The important part is that if this is x2, that has to be y2, that can't be y1. So arbitrarily going to label the first point with the 1s, second point with the 2s, and dropping them in this formula. The other thing to be careful is the formula has a minus because we are subtracting, we're finding that change in the difference. And so always write the minus, and I'll show you what I mean by that. So here we would have m equals y2, 3, I'm writing that minus, that one right there. And now I look and see what's coming up, 3 minus 7. Okay, cool. And then here, x2 would be negative 4. Again, I'm writing the minus regardless of what's about to happen. Minus x1, but this time it happens to be a negative. And so I'm writing that out really clear, minus that negative so that I can see my signs so they don't mess it up, because that's where everyone screws these up. So 3 minus 7 would be negative 4, and this would be negative 4 plus 2. So that is negative 4 over negative 2. Double negative would be positive, and 2. So that'd be our slope there. Okay, so 3a is find the x and y intercepts of the following equations. I think there's a couple examples coming up, and use the intercepts to graph. So here, try doing this as a table. I don't think I've shown this way. This is kind of just a nice shorthand way if you're finding intercepts from standard form. Remember, standard form is when the x's and y's are on one side and the numbers on the other. I'm just setting up this table saying I'm going to let x equal 0, and then that's going to knock out that x right there. And then 5 times something makes 10, so that something's got to be 2. And then if I let y equal 0, and this was in that last section, remember, dividing over 2, then that would get us 5. Once you get kind of comfortable with the idea of intercepts, these are super easy. You just, okay, x is 0, gone. Okay, 2, y is 0. Okay, so that's got to be 5. So there's my intercepts. When x is 0, y is 2. And when x is 5, y is 0. So that would kind of look like that. And so we used our intercepts to graph, and then we're just use the graph to calculate the slope. Okay. So then it looks like from this, I'm going to use that as my starting point. Looks like we are going 5 over, so again, rise and run. So we're going right 5. And then from there we have to go down 2, so that's going to be negative 2. So my slope would be negative 2/5. Okay, so these next two examples are graphing a line given a point and a slope. This is such a handy technique to have because you don't need an equation and you don't have to make a table at all for graphing lines generally. Sometimes they show up in not the best form, but a lot of times you can just look at them and draw the picture and not plug a bunch of points. So that's where we're trying to get to, and this is something that'll help with that. So to graph this, all I'm going to do is I'm going to graph this point because I know this is on the line. So when x is 0, y is 4, and then let me write that slope a little bit larger. So negative 1/3. And I always think of the negative in the numerator, and I always think of working to the right. So this is again rise, and this is run. So once I have a point, this is telling me like where to go. So it's telling me I need to run 3, so I go 1, 2, 3 over, and then to drop 1. And then there's my next point. If I want to make a couple of points and draw a barrel line, again, we're just counting over 1, 2, 3, drop 1, 1, 2, 3, drop 1. And then connect that with a straight line, which is easier said than done. For B, same thing. This one happened to be an intercept, but that's the thing, it doesn't have to be an intercept. If we have any point and the slope, there's only one thing that can happen. So here we're going, x is negative 2, y is negative 3, and then from there, our slope is 3/4. So we're gonna run 4, so 1, 2, 3, 4, and we're gonna rise 3. And then there's the graph of my line. And I mean, I don't even know what that equation is, but that's exactly where that line goes. Okay, number 5. Lynette is saving money for down payment on a new car. Figure below shows the amount A she has saved in dollars in W weeks after the first year. So how much does Lynette save each week? So looking at this graph over here, so W, this is our weeks. And then this is our amount saved. And so how much does she save a week? Well, it looks like here in week 1, she went from 200 to halfway between those boxes. So let's see, this is 200, so this would be 300. So that would be 250 there. It's halfway between 2 and 250, so I'm gonna say 25 bucks. And then there's a thing on these graphs, when this is hard to read on the computer, and that's what this is a picture of the computer graph. Right down there, there's a little magnifying glass. If you click on that, it will make this graph bigger and way easier to do what I just did. And so definitely check that out, especially if you're working off of a small screen. B, give the coordinates of W, A, any 2 points in the graph. Okay, so we're just going to find 2 points on here, and we're going to use those coordinates to compute the slope. So I picked this one because it looked easy and I could read it. And so here at 0 weeks, it looks like she has 200. And then the next one I picked was out here because, again, it looked easy. It was on the 400 and I could read it pretty easy. So 8 and 400. You could have picked, you could pick 1 and 225, and that would actually make it a bit easier. But those are the ones I happened to grab. And then to do the slope for that, so we'll go y2 minus y1. That's 400 minus 200. And then x2 minus x1. So 200 up top over 8, and that is 25. And what are the units of the slope? So the amount, so remember it's rise over run, so it's y's, changes in y's over changes in x. So amount would be dollars, and the x is in weeks, or week. So this would be dollars per week. So $25 per week. So what does the slope tell me about the problem is that she's saving $25 per week, which is what I estimated when we look back here in part A. So confirming that by finding the slope.